This is Professor Robert Nading, and I'm back with Using Desmos in Math 168. Today I'm going to be covering looking at the standard normal curve with Desmos and finding the area under that curve. So if we review just slightly that the standard normal curve is deviated approximately plus and minus 3 standard deviations or 3 z-scores to the left and to the right. The green value, or 1 standard deviation minus or 1 standard deviation plus, holds about 68% of the data. Remember, these are approximations. As we see different values, and whether it be stat key, whether it be Desmos, or whether it be by hand, we'll see slightly different values, but they're all very relatively the same. If we go out to 2 standard deviations, we hold approximately 95% of the data. And then you can see that the 2 red tails are holding approximately the additional 5% or 2.5% on each side. So how do we look at this inside of Desmos? Okay, well, in Desmos has a command for a normal standard distribution. And just like at any other time when we talk about Desmos, I'm going to clear this out of my way. When we go to enter things, we can also use the keypad GUI. And the keypad GUI is nice because the functions are all labeled for us right here. Stats, all of our statistics are right here. And in distribution, all of our distribution is right here. Since I'm doing distribution right now, I'm going to probably go back and forth between this because some of these are a little long to type. However, though, the normal distribution is normal DIST. As soon as I enter normal DIST into here, the standard is 0, 1. And if I don't do anything, the curve I'm looking at right now is 0, 1. If I click on the zoom fit, I see the 0, 1 distribution. If I put 0, 1 in here because I feel better, then I see the same exact curve. So there's no difference at all in those curves. If I want to find cumulative probability of this curve, I simply click on the cumulative probability, and I see that underneath of the curve right now is 100% of the data. And the endpoints are negative infinity to positive infinity. Those are the defaults. If I want to change those, so let's do what we just had. Let's do -2, and let's do +2. And you can see that the curve changes to approximately 95%. So the curve now holds approximately 95%, centered up on a 0, moving 2 standard deviations to the left and 2 standard deviations to the right. I want to make a different curve. And I like to use control copy often because it's kind of nice. I'm going to get rid of that normal curve. I'm going to make a new normal curve. I'm not going to center up on 0, but I'm going to center up on 6. My curve centers on 6, and it's going to have a standard deviation of 2. Again, remember, zoom fit, and here's my new curve. So you can see the difference between a curve that centers at 6 and has a standard deviation of 2. If I were to compare that to something similar, I had a standard deviation. If I moved the center, remember 8, all I'm doing is moving my center of my curve, if you will, but I'm keeping the distribution exactly the same. Those 3 show a nice play between changing the mu value, simply slides the curve to the left and to the right. If I were to do all these same things, but I were to go in and I were to change instead of the center point, I make all the centers exactly the same this time. So in essence, they're all laying on top of each other, but I change their standard deviation. Maybe I make this one a 1, this one a 2, and make this one a 3. You'll notice what happens, and if I get a nice picture here so we can see them all, actually, let's do this one here. You can see that what happens is the only thing I change here is the breadth and the height of the curve. Why? Because I've now done the standard deviation. Remember, I have to hold 100% of the data underneath of all of these. 100% of the data is in the purple, 100% of the data is in the black, and 100% of the data has to be in the red. And if I'm holding those data points, I have to make sure that when I stretch the data, it comes down. But when I compress the data like the purple, it has to increase to go upward. A curve cannot remain the same height if it has different width. And that's kind of how you want to look at it when we're talking about distributing. So let's get rid of these distributions and let's come up with some new stuff here. So let's say that we want to, do one here. Let me follow this. So let's say we want to sketch a normal curve with a mu of 10 and a standard deviation of 4. That's our standard deviation or our sigma marking. So we're going to go with a 10 on a 4. That's going to be so easy, we're not even going to be able to handle it. So it's the normal distribution. If you just want to type it, it's the normal distribution. Remember, our normal distribution is going to be centered up on a 10, and it's going to deviate by 4. All we have to do is tell Desmos that we want to be on a center of 10, comma, we want to distribute by 4, and we want to hit the zoom fit, and we'll have our center distribution. If I want to see the area under that curve, I can see the area under the curve right there. If we look at 10 and we were count over by 4, 1, 2, 3, 4, there's one standard deviation. 1, 2, 3, 4. There's 2 standard deviations. So right there is 2 standard deviations. And I can prove that to myself by going -2, going +2 on my standard deviation. I went from +2 down to, actually, let's go -infinity here. So the left tail, you can now see, is going from here to here. If I just want to look between the two, maybe I want to look between -2 and +2, I can look at those deviations also. Excuse me, not +2. I have to go the other direction. I have to go 1, 2, 3, 4, 1, 2, 3, 4, which is going to put me at 18. And I got to go to 18 on the top. And I want +2. That's why that keeps messing with me right there. So there's my 95% curve area. Works out pretty nice. Let's do another one. Let's see what else we can find. Let's do an area below 40 of a normal distribution of 30 with a standard deviation of 10. So the 3 important pieces of information here that I have to have are, 1, I want to sketch below 40, but at the same time, I want to have a center of 30 right here, center of 30. And I want to have a standard deviation, which is about 10 right here, and 30. So we could do this by hand, but we can also do this with technology. So let's put a 30 and a 10 together first. Let's change it to 30. Let's put it on a standard deviation of a 10. Let's get rid of these. Now, just all you gotta do is highlight these, delete, and highlight and delete, and it'll come back to the normal. And there it all is right there. Now, remember what it said, though. It wants the area below 40. So below 40 means that the maximum number I'm going to have is 40, and the minimum I'm going to have is -infinity. There's the area right there, and the area correlates to approximately 0.8413. That would be my area for this value here, and that would be my sketch according to it. Let's do the area above a 10 if we're on a 30-10. So we're on the same distribution of 30-10, but now we're taking the area above 10. So we'll go back, we'll change. Instead here, now my minimum is going to become 10, and my maximum, just get rid of this, click outside of it, and it becomes infinity. And this is my sketch of my area above 10. Notice my area is approximately 977, 0.977. What if we want to go an area in between something? Okay, so we have an area in between 30 and 50, and again, we're on the same distribution of 30 and 10. So let's go between something. So let's go between 30 and a maximum of 50. And my area shading is here. And my percentage is approximately 0.477. Couldn't be any easier. We'll do one last one. We'll do this exercise. If a test is normally distributed with a mean of 60, so now we have a mean value of 60, and has a standard deviation of 10, so we're going to have to put a 60 and a 10, what proportion of the scores are above 80? So now we're actually looking for that percentile that's above 80. So let's put a 60 with a 10 deviation and go above 80. So we go here, we put a 60 with a 10 deviation. Remember what it wanted is it wanted above 80, so the minimum is going to be 80. However, though, we have to get rid of the maximum, and we have to let it go to infinity. And I'm going to put it on a nice picture so we can see it. It's right here. That's the tail we're looking for. The question was, what is the proportion? The proportion is right here, 0.0227, or approximately 2.3 when rounded percentile, depending on what the question wants. But the proportion I would write as the p-value of 0.023 if I was rounding to 3 decimals. Looks good. You can try some of these other ones if you want to, and put these in and find your normal distribution and see how it fits. On the next video, I'll do the reverse and I'll do the inverse variation where we find the actual endpoints given parameter populations.